Hello and welcome back to 17.1. We're going to be going over Explain 2, where we're solving a real-world problem involving arc length. So just so you know, let's say I have a circle. Okay, circle. It's not perfect, but it's there. And I have a radius, which goes from the center to the edge. Okay. And I wanted to know an arc length S. So let's say, think of it like a piece of pie with a central angle of theta, because I don't know what that is. It could be 10 degrees, could be 45 degrees, I don't know, but it's a degree of an angle. And I wanted to figure out the length of that arc length. So if you ever went flying, you're not going over like a direct distance, because a lot of students think, oh, I get into a plane and I'm flying straight across. Well, the Earth is curved, so you're probably kind of really more like in a plane following that curve and not a straight line. Still really fast to get on a plane, but that's kind of why it's important to know all this stuff, because we use it for navigating everyday life from GPS and whatnot. So this is just a formula that we can use. If we know the radius and we know the angle, we can figure out the arc length. Okay. With that being said, let's go over part A, a word problem. Our favorite, the sun. Alright, we know it's about the sun, which is also circular in nature. It's a sphere. It says a point on the sun's equator makes a full rotation in about 25.38 days. So that thing actually rotates. That's kind of cool. Alright. Just so you know, full revolution, just so you know. So going all the way around is not only 360 degrees, but it's also 2 pi, just so you know. And the sun has a radius of about, wow, that's a lot, 432,200 miles. That's a big radius. What is the angular velocity in radians per hour of a point on the equator? Okay. What is the distance around the sun's axis? Does the point travel in 1 hour? Okay. And how does this compare to the distance of 1,038 miles traveled by the point on the Earth's equator in 1 hour? Okay. So a lot of stuff. There's like 1 question mark, 2 question mark, 3. So there's 3 questions we got to answer. Okay, let's start with the first one. Let's find first the angular velocity in radians per day. Okay, so first of all, in the problem they said that it goes in 1 revolution, so 1 full revolution, in how many days? They said in the word problem. 1 revolution in about 25.38 days. Alright, now we're going to convert that to radians per hour. Okay, so that's again 25.38 days. Alright, so, well, how many hours are in 1 day? 24, right? So notice that days is gonna kind of cancel out, because just like in math, variables cancel out. Hey, words can cancel out too. And at least I'm left with 2 pi, or 2 radians, times 1, which is 2 pi radians. And 25.38 times 24, which is about how much? 609.12. Now let's equate that to an actual like decimal answer, because that's a little bit easier to work with, especially for the next 2 questions we have to deal with. So let's divide 2 pi divided by 609.12. Go ahead and do that now. And that would be about 0.0132 radians per hour. And that's our angle. Okay. Alright, so first of all, the next one we're going to do is this is what is the distance around the sun's axis does the point travel in 1 hour? So we want to know that, remember we figured out S length. So if they want to know how much it kind of covers, in our little sun from one end to the other. Let's go ahead and figure out what our radius is. Our radius was 432,200. So we'll plug that in. And our angle measure is 0.0132. And go ahead and take some time to calculate that out. You will probably get a decimal, but it should be about 4,460. All right. So that's the sun's kind of time to get around the Earth, whereas our time to get around the sun's way of rotating. But for the Earth's rotation, which is about 1,038, well, which one's more? The sun's or the Earth? Sun, right? About how many times more is the sun than the Earth? Would you say twice as much, 3 times, or 4 times? Just as a guesstimate without even calculating, I think it's about 4 times as much. Probably. Alright, so we answered the first question, converting it, and finding the angular velocity in radians per hour, the distance, and then how it compares to the Earth. Alright, moving right along to letter B. So they say the Earth's equator is a latitude of 0. So if you ever look at the Earth, this is Earth. There's usually a latitude, that's our equator. That's usually our 0 level, kind of the very middle of our Earth. It looks like equator, right? That's my picture. The Arctic Circle has a latitude of this degree, 66.52 degrees north, and the diameter, so that our diameter is 7,926, so all the way around. Wow, okay. The diameter of the Arctic Circle is of course less than that. So if you think of the equator, that's this piece, the middle piece, and the Arctic Circle is probably going to be a little bit smaller, right? Actually, it's north, so it's probably going to be that piece, which is way smaller than the equator. Alright, with that being said, let's go ahead and see what they want to know. It says every point on the Earth completes 1 revolution. And remember we said a full revolution around a circle is either 2 pi in radians or 360 degrees. Now in this case, do they want degrees or do they want radians? Yes, degrees is a dead giveaway. It's going to be 360. So it completes 1 revolution every 24 hours. This is a whole day, just like you're spending time in the day. 360 degrees is what the Earth completes in 24 hours. So the angular velocity is going to be, well, what was our degree? Which was about 360. And how many hours are in a day? In 1 day. Well, there's 24, right? They even said it right here in case you forgot. And here, you'll notice hours kind of cancels out. And we're left with 1 times 360, which is 360. 24 times 60, which, I mean, if you wanted to calculate that out, plus they're going to ask us to use it to divide out, so we might as well do that now. That would be about 1,440. Let's divide that out. 360 divided by 1440. That's about 0.25, well, 25 degrees per minute. So the angular velocity is about that many degrees per minute. Okay, let's look to see what part B wants us to do. And just keep that in mind, we might need to use it. I don't know. Okay. So here it says for part B, How far does a point on the Earth travel in 15 minutes? Well, they want to know how much it travels in 15 minutes. So this is what we found from part A. And in 15 minutes, let's figure out what 15 times 0.25 to figure out how many degrees it moved in those 15 minutes. And that would be about 3.75. Alright, the next thing they want us to do is, it says write a proportion to find the distance to the nearest tenth of this represents, as this represents at the equator where the circumference is. And I like that they at least give us our circumference, which is nice. So this is how much our circumference is, just in case you didn't know. That means if we kind of went all the way around the world, that would be 7,926 miles if you went all the way around the world. So for here, that would be 3.75, right, divided by how many degrees are there total around the world. If I did one revolution, do you guys remember? Is it 2 pi or is it 360? 360, right? Now, x is what I want to know for just that little portion. And we're going to put this over pi. Okay, let's go ahead and cross multiply these. In fact, if I wrote this out just so you can know where they got this from, I cross multiplied 3.75 over 360 equals x over pi times 7,926 miles. If I cross multiplied those together, I get 360. X equals 3.75 pi times 7,926. I want to get x by itself. What's the opposite of multiplying? Dividing. Now I know I haven't computed actually any numbers yet, but we're going to get there. Notice how those cancel out, and I'm left with x equals 3.75 pi times 7,926 divided by 360. Now is the time, you guys. Go ahead and calculate that out. 259.4. Alright, that means a point on the equator travels about 259.4 miles in 15 minutes. All that, right? And is there any other questions they wanted us to write down? Actually, yes, there is. They want us to find out how long will it take a point on the Arctic Circle to travel this distance. So, remember for circumference, just in case you didn't know, circumference is going to be equal to pi times our diameter. Okay? So, you remember our diameter of our Arctic Circle is about 3,150. So that would be pi times 3,150. Alright, so here is our miles for the Arctic Circle. We're going to write that over our circumference. So they just kind of took this and plugged it in right over here. And then one revolution, remember, one revolution all the way around a circle. Would that be in degrees? 2 pi or 360 degrees in this case. 360. Again, if you're wondering how did they get from here to here, so let me write that out. It's just basic proportions, but sometimes it's nice to see the steps, so I'm just copying down 259.4 over pi 3,150 equals x over 360. So what I'll do is I'll cross multiply, and I'm left with 259.4 times 360 equals x times pi times 3,150. Now I want to get rid of what's being multiplied to x, so x can be by itself. What's the opposite of multiplying? dividing. So I'm going to divide both sides by pi, 3,150. And what will end up happening is these will cancel out and that's canceled out. And I'm left with x equals that. So take some time right now, guys, and go ahead and calculate that out and see what you get. And that should be about 9.437. Okay. Alright. And the last part they're asking us to do is use the angular velocity to find the time, t, to the nearest hundredth required for a point on the Arctic circle to move through an angle of rotation at about 9.437, which is what we got on the last problem. Remember, that's about 0.25 degrees per minute. So what's the opposite of multiplying? Because that's what that means, parentheses. Divide, right? So we're going to divide both sides by 0.25 to both sides. Go ahead and calculate that out. What would that be? That would be about 37.75, which means it takes about 37.75 minutes for a point on the Arctic Circle, so at the top, to travel the same distance as the point on the equator that it takes 15 minutes. Okay? Alright. So just like it says here, stop and do the problems in your packet, which is a word problem, and then we'll come back to go over the homework and the checkpoint.